Thank you once again for watching my video. My name is Mr. Charles Weniken. In this video tutorial, we will discuss fuse rating and where we will find fuse rating on its body. You remember in our first video, I talk about fuse rating, which I said the fuse rating is usually on the side of the fuse. Now this is what I will show you right now. Now look at the example of fuse rating. Now fuse rating is written on the fuse. Now this fuse is 13 amps. It's obviously that you can see that this one is the fuse and it is written on its body 13 amps. This one is 13 amps, while this one is also 13 amps. Sometimes the fuse rating is written on the end of the fuse, which you can also see it, but this one is not too clear. But if you have seen these types of fuse or this kind of fuse, check on it, you will see the fuse rating on the body. So the example of fuse rating which you are seeing right now is 13 amps. Both sides is 13 amps, but this particular one is not too clear to see if it is 3 amps, 5 amps, or 13 amps. Now, typical fuse ratings. Typical fuse ratings. Now, I want to use this area to give you brief fuse rating of some of things we use in our home, just like as I explained from the first video. Remember, this fuse video it will be a series, and this series it will be very long. I may not tell you that it will be maybe 6 videos, 7 videos, 8 videos. I don't really know, but this particular fuse rating video it will be very long, and I shall be treating it one after the other or one by one. Now, typical fuse ratings, we have clock radio 3 amps. I want to use this to explain each of the home appliances which we use and their fuse. Clock radio 3 amps, coffee maker 5 amps. I'm talking of the fuse. Dishwasher 13 amps, DVD player 3 amps, electric blanket 3 amps, fan 3 amps, food mixer 3 amps, fridge 3 amps, hair dryer 13 amps, hi-fi 5 amps, iron 13 amps, kettle 13 amps, laptop or PC 3 amps, microwave oven 5 amps, radio 3 amps, table lamp 3 amps, toaster 5 amps, TV 3 amps, vacuum cleaner 3 amps, video player 3 amps, washing machine 5 amps. All these are what you should consider or put in your score in case if you have all this in your home. Try to memorize them and know each of the fuse they are using. Now the question goes in this way: why are fuses rated? Exactly. Fuses have different rating, so they can protect different electrical circuit. That is why fuses are rated. They have different rating as well. They can protect different electrical circuit. Remember what I explained of electrical circuit. Anything that uses what? Electrical current is all about electrical circuit, which I gave you an example: iron, kettle, television set. Those things uses what? Electrical current. So in this case, fuses have different rating, so they can protect different electrical circuits, which is very right. Different electrical circuits are different amount of electrical current. Exactly. Some of the current or some of the circuit might use 5 amps, 13 amps, 3 amps, all depending. That is the reason why fuels are rated. That is the most important reason why fuels are rated. It's because of the different electrical circuit. Because you cannot compare iron to television set that they will use the same fuse rating. It's not possible. They are numerously that which I gave you the examples here now. Let me go back. You can't compare coffee baker 5 amps to dishwasher to use the same fuse. It's not possible. So that is why the fuse are rated. It's very, very simple for you to understand why the fuse are rated. What may be too much electrical circuit for one electrical circuit may not be too much for a different electrical circuit. That is simple truth. If your home appliances, one of them is using 13 amps and the other one is using 5 amps. 13 amps circuit is electrical circuit is greater than or bigger than 5 amps, and 5 amps is bigger than 3 amps. So that is how it is. The one that is too much for 3 amps may not be too much for 5 amps. The one that is too much for the current that is too much for 5 amps may not be too much for 13 amps. That is why the fuse are rated. That's why the fuse are rated. So a fuse that glows at say 10 amps is no use in an electrical circuit. That uses 12 amps, the fuse would blow during normal circuit working. That is just how it is. Just I have already explained it. Use the typical fuse rating of what I've just showed here to judge what I am trying to explain. They are in different fuse altogether. You can use microwave oven 5 amps to compare with what vacuum cleaner of 3 amps. The voltage will be, the current will be higher in 3 amps, being the fuse will be cut off. But once it is vacuumed, the microwave oven, once it's 5 amps, it uses 5 amps. If you use 3 amp fuse, it will not be sufficient. From there, it will be having an issue. How to calculate the fuse rating? This is just as I told you before that I will explain on how to calculate the fuse rating. Using the guideline that the fuse is rated at 125% of normal operating current. The fuse is rated at 125% of normal operating current. That is why we are using this 1.25, because 125%, anything that has percent, it means 100, which I use 125% divided by 100. That is why we are having 1.25 for you to understand it. So what I'm trying to explain here is using the guideline that the fuse is rated at 125% of the normal operating current, which is power is in watts, current is in amps, and voltage is in volts. Therefore, current is equal to power all over voltage. Current is equal to power all over voltage. Therefore, fuse rating is power divided by what? Voltage multiplied by what? 125%. I repeat, fuse, using this guideline that the fuse is rated at 125% of normal operating current, which I said, as as we are saying 125%, percentage is 100. I use 100 divided by 125 divided by 100. It gives off 1.25. Now, in this case, power is in watts, current is in amps, while voltage is in volts. Therefore, to calculate for current, which gives us power divided by voltage. And therefore, the fuse rating goes in this way: power divided by voltage multiplied by what? The normal operating fuse, which is 125%. Or put another way, which fuse is rating is power divided by what? Voltage multiplied by 1.5% and 1.25%, which I use the 100 to divide by 125. So in that case, the fuse rating will be using this calculation, which is rating. Fuse rating is equal to bracket and close watts. This watts represent power, while these volts represent voltage, because we are using the unit of power to represent in this area, the unit of volts to represent here. The unit of power is watts, while the unit of volt is voltage. While this 1.5 is what I use to calculate the normal operating voltage. I use it to divide by 100. That is how to calculate fuse rating. For fuse rating calculations, now let's take this assumption. This is just an example in case if you don't understand what I explained there, use this one to understand it much more. Now, the assumption in this calculation is that there are only 3 fuse ratings. Try to understand what I'm explaining here. This is an assumption. I am not saying that it must be 3. I am assuming that the assumption in this calculation is that there are only 3 fuse ratings, which is 3 amps, 5 amps, and 13 amps. Say this power is 500 watts. Remember, power is 500 watts. Remember, this 500 watts will be here. And just as I said, all depending on your country in terms of volts. If your country is using 120, is using 240, is using 260, all depending on your country. In Nigeria here, we use 240. Now, this fuse rating is equal to this, which is the formula. You apply the formula. Secondly, you substitute it. 500 watts represent here will be here. 240 volts will represent here. Why? This is the constant value. Once you divide it, 500 divided by 240, this is what it will give us. If you have a calculator or a handset, whatsoever thing that you are using, you can calculate it and you will see or get exact value of what you are seeing here right now. So multiply it by 1.25. This is what you will have. Now, what you should remember is you will do what? Approximate it. Just as I said, in this assumption, and the assumption in this calculation is that there are only 3 fuse ratings: 5, 3, 5, and 13. Now, in this case, we have 2.6, 2.60, 41, 667. So, in that case, we will use this 6 to approximate it for us to have exactly 3 amp fuse. That is what I did here. The next fuse up is 3 amps. 3 amps fuse, which is used for television or for any other thing. That is how to calculate for the fuse. And I want you, if you don't understand it now, you can rewatch the video, you will understand it. Now this one is for 13 amps. For 13 amps. In this 13 amps, we said here is 1,500 watts. The same normal constant voltage, depending on your country. Now it's the same thing. 1,500 watts divided by 240, it gives 6.25. Multiplied by 1.25, it gives 7.8 1, 3, 6 amps, which under normal thing we don't have. From what I said before, we don't have, we are using 3, 5 and what, and 13. Now under normal thing we don't have 8, we don't have 9, all we have is 13. It means that we will approximate it to 13 amps fuse. This is just an assumption that we are assuming that we only have 3, 5 and 13 amp fuse. Is an assumption. Exactly. So let's proceed more. This is for calculation of 13 amps fuse. Now this is for 5 amps. Let's say 5 amps fuse in times of power or watts is 900 watts. So you substitute it as a normal thing. 900 divided by 240, it gives us 3.755. Multiplied by 1.25, it gives 4.6875 amps. Now the nearest fuse amp, it should be what? 5 amps. That is just a simple calculation of fuse rating. Is as simple as ABC. Now for electrical drawing and circuits, there are 3 symbols of fuse we can use. The following images show the symbols of fuse along with their standard. Look at it here. This one is for the standard. The standard. All these are the symbols of fuse. This one, all these symbols that you are seeing here, IEEE, AN, IS, and so on and so forth. This one I can remember is Institute of Electronics Engineering, which I can recall it. But the other one you can as well go and find the full meaning of it. So these are the symbol of each of them. In case if you are to read a circuit, always take this symbol to understand that this one is fuse. All this symbol represents fuse. It's very, very important for you to know each of the symbol and where, in case if you are for interview and they gave you a circuit diagram to study and explain what is there, you can use it to explain that this one is fuse and this one is fuse and this one is fuse, all dependent. Now I want to show you examples of fuse. These are the examples of fuse, and these are the types of fuse as well and their examples. This one here, is it resettable fuse or rewindable fuse? We will discuss it as well. This one is drop out fuse, where you will see it in transformer. This one you can also see it in our various homes as well. This you can also see it in our circuit, television, and every other electrical circuit. This one you can also see it in our car. You know, some of our cars now, they use this fuse as well. This one you can also see it in our cable, where we are using to power our desktop, 13 amps fuse, and so on and so forth. All these things will be treated in the next coming video. These are the examples of fuse. This one is another examples of fuse. This one is surface mounted fuse, and this one comes from a resistor. All these ones are fuse as well. All what I'm showing you right now, they are all fuse examples. Thank you once again for watching my video. Please, if you find my video useful, subscribe to my channel, comment, like, and share. Thank you once again. See you in the next class.